Good morning. I hope everybody's having a good e-learning day so far. So today we are going to be talking about indicator 11.2 or 11 day 2. And we are going to do a quick review from yesterday, and then we are going to go into the new content, which is evaluating functions. So as a quick review, yesterday we talked about a relation is just a set of ordered pairs, and a function is a set of ordered pairs that meets certain standards, or it passes a test. And the test is that each x can only be used once, or can only go out to one y. And so you can be given those ordered pairs in just a list with the fancy brackets. You can be given those ordered pairs in a vertical or horizontal table, or you can be given those ordered pairs like pictured here in a diagram. And so no matter how the information is given to you, you still just look at the x's, okay? It also can be given to you in a graph, already graphed for you. And if it's given to you as a graph, you just apply the vertical line test. And you see if along the entire graph, if you draw a bunch of vertical lines, if your graph never loops back around and touches one of your vertical lines a second time. If you're given your relation in a table or in a list or in a diagram like this listed, then you just simply look at the x's, right? You look at the x's and you ask yourself, is there a repeating x? Or like I kind of sillily said yesterday, a cheating x, right? So if you look at this example on the left here, that is a function, because remember, these are your x's and these are your y's. And if you look at your x's, you have the x of 1, 2, 3, and 4. And the x of 1 only goes out to one y, the x of 2 only goes out once, the x of 3 goes out once, and the x of 4 goes out once. So this would, yes, it would be a function. If you look at this example on the right, you've got your x's and your y's, and you just look at your x's, and the x of 9, that's your cheating x, right? So this would it would not be a function, and the reason is because of x equals 9, because the 9 goes out to a 3 and a negative 3. Okay? And again, it doesn't matter what the y's do. Y's can do whatever they want. So if you have multiple x's going to one y, that's okay. You just cannot have your x going out to multiple y's, right? No cheating x's. All right, so that's kind of our very quick review of yesterday. Now we're going to move into our new content for today. So a couple of different things that are new on your worksheet that you have for today. The first 6 or 8 on your worksheet is just a review from yesterday. It's graphs, do the vertical line test. It's relations given to you in tables and in lists and in diagrams, and you just simply, does it pass the repeating x test? If it does not, right, it's not a function, and then you just tell me which x is the offender. So now we're going to look at determining if it is a function if you're given an equation, okay? So if you're given an equation, you have to graph it, okay? So right here, this is step 1, which is we have to graph the equation. So this takes us back to multiple indicators that we've been going over the last couple months of how to graph equations. Well, we've got y equals 3x plus 2. That's y equals mx plus b, okay? So I'm going to give myself a graph here, and I'm going to sketch the graph, all right? So the first step is to sketch the graph. So we always start with our b, and that is our y-intercept, and this is our y-axis, so that means we're going to put a point at positive 2. Then we are going to use our m, or our slope, to move from our y-intercept, and in this case, we're going to go up 1, 2, 3 over 1. We could also go down 1, 2, 3 backwards 1, because 2 negatives make a positive. And then we can connect this with a line. Okay, so we're going to connect these points with a line. Okay, And now we have a graph that we can look at, and we can ask ourselves, does this graph pass the vertical line test? Well, if you remember me, I told you yesterday, every line that has a slope is always going to pass the vertical line test, because this line goes on and on forever at a slant. And so if you look at your vertical line test, right, if we take just a let's go real thin here. If we take just a real thin line and we check to see if it passes the vertical line test. So I'm just going to draw some vertical lines here, right? So vertical line test, check, it only passes there. Vertical line test, check, it only passes there. Vertical line test, check, it only passes there. And it will forever and ever and ever, because the line continually slants. So does this pass the vertical line test? The answer is yes. And so yes, it is a function. Okay? So now let's graph our second one. So let's give myself a coordinate plane here. And again, this is my y's, these are my x's. And I'm going to graph the point of y equals 1. Well, y equals 1, that just means on the y-axis, at the point 1, 2, positive 3, we put a point, okay? And then we draw a line on that point. And remember, y's horizon, so these are horizontal lines. Okay, so does this horizontal line pass the vertical line test? Well, of course it does, because, right, every vertical line that we try to draw intersects our blue line at just one point. The blue line never circles back and touches one of our pink lines again, right? So this definitely passes the vertical line test. So yes, this is a function. Now let's graph our last one, which is x equals -2. So again, let's give ourselves a graph here, and this is our y and our x. Well, at x equals 2, x equals -2, on the x-axis at -2, we put a point, and then we graph that line, right, straight up and down. Well, this is a vertical line, so this line cannot pass the vertical line test because it is itself a vertical line. So if we tried the vertical line test and I tried to draw a vertical line, it hits constantly, right? It doesn't just hit at one point, it hits at every point. So no, this would not pass the vertical line test. This would not be a function. Why? Why would it not be? Well, literally x is -2. It hits a ton of different places, right? It constantly, your pink line and your blue line hit at every possible point right here at the x equals 2. So x equals 2 is your offender because the entire line sits on x equals 2. So as a recap, okay, lines with a slope, okay, any linear equation with a slope, any kind of slope, is always going to pass the vertical line test. A y equals is always going to pass the vertical line test. An x equals will never pass the vertical line test because x equals whatever is always a vertical line. And a vertical line, just based on its very existence as a vertical line, fails the vertical line test. Okay, so linear equations with a slope, always yes. Y equals, always yes. X equals, always no. Okay, so that is if you are just given an equation, you need to graph that equation, or if you can remember the rules I just said, which is anything with a slope is always yes, y equals is always yes, and x equals is always no, you don't even have to go to the trouble of graphing it if you can remember those rules. But if you don't remember those rules, graph it and then check it with the vertical line test. All right, next we have, I believe this on your worksheet is like numbers 11, 12, and 13. Well, with 11, it's just a graph. So on your worksheet, that's your homework, 9 and 10 are like the examples we just did, okay? 11 is just simply a graph given to you, and you just, does it pass the vertical line test? Numbers 12 and 13 on your worksheet, here's an example of a problem like that. So again, right, does it pass the vertical line test? That's our question, right? This right here. Whoops. That's our question. Does it pass the vertical line test? Well, we cannot connect these dots because these may not be all of the dots of the relation. We don't know, and we don't know in what order they're connected, right? So don't put this part in your notes, right? But if I connected these points like this, then they do pass the vertical line test, right? But if I connect them differently, right? If I connected them like this, oops. It's not letting me change colors. There we go. If I connected the dots or the points like this, well, now it doesn't pass the vertical line test. So when you are given points that are not connected, right? That are not connected, you cannot assume how they connect because you just saw I could connect these points and make it a function or make it not a function. So if you're given a graph with just data points and no lines connecting them, you can't connect the dots on your own. You just have to go by the points and you just have to apply the vertical line test. So you look at all the points. Are any of them straight up and down on top of each other, right? Do they pass the vertical line test? Whoops. All right, so going through this point, that passes the vertical line test because that point is on that pink line, but no other point touches that pink line. And then we run a line through there. Only one point there, we're good. Only one point there, we're good. Only one point there, we're good. We're good. We're good. So we ran a vertical line through each point. Never was there 2 points on a line, so yes, this would be a function. Okay, now let's look at this second example over here. This one. We do the vertical line test. We're good so far. We're good so far. Fail. Okay, no, it is not a function. Why is it not a function? Well, it's not a function because of, well, let's name that x. If you look at, this is 1, 2, 3, 4, so this is negative 1, 2, 3, 4. So right here at negative 1, x equals negative 1, right? Right here at x equals negative 1. It fails because it touches twice, or 2 points are on one vertical line, right? Now, if you go the rest of the way, it passes fine, but that doesn't matter because it only takes one fail to make it not a function, okay? So, and again, right, if you look at where that vertical line was, that's x equals negative 1. Oops, sorry. Right here is x equals negative 1. So at x equals negative 1, this scatter plot fails the vertical line test because at x equals negative 1, there are 2 points on that vertical line. Okay? So again, if you're given a graph and the line is already drawn, you can do the vertical line test with the entire line. If you're given a graph with just data points, don't connect them, just simply do the vertical line test with the given points that you have. And if you have any that are straight up and down on top of each other, then they fail the vertical line test, and just tell me why they fail. All right, so on to the kind of the biggest chunk of this new material is evaluating functions. So when we evaluate functions, what that means is that we are going to plug given information into a function. So a couple of things I want to cover, and I covered this with some of you, but some of you I didn't have time yesterday, so this might be a review and this might be new material here. All right, so if you'll notice right here on this line, I have 3 functions. I have f of x equals 3x plus 2. I have g of x equals x squared plus 2. And I have h of x equals 3x plus x plus 2. And remember, if you, a ways back, I said that f of x equals a fancy y, okay? So I could actually rewrite this as y equals 3x plus 2, okay? The important thing to remember here is that g of x and h of x, it's the same thing as f of x. It's still a fancy y, okay? The only reason you have f, g, and h is because you need to name them. So this would be like saying I have, Bob, George, and I don't know, Betty, okay? It's just their names. It doesn't change anything. It doesn't make it any different. It's just telling you, it'd be like if I color coded them, right? Let's say that I called this one the blue one, right? And so I said blue equals 3x plus 2. And then this one I called purple. And so I said purple equals x squared plus 2x. And this one I called pink. And so I said pink equals 3x plus x plus 2. It's just a way of naming them or keeping them separate. So if I wanted to talk about them or if I wanted to give you instructions on what to plug into each one of them, I could tell you, I could just call them by F, G, and H, right? It's just their name. So they all are y equals, okay? It's the same thing. They all are y equals. They're all just fancy y's. And the F, the G, and the H are just their names or the way we distinguish or tell them apart, okay? So when you are given a bunch of different functions in the directions, and then you're given several, and we've got 6 here, right? You're given 3 functions, and we've named them F, G, and H. And then if you look here at number 1, this tells you F of negative 2. Well, the F just tells you to use the F function, right? So since it says F of something, since it says F of negative 2, that tells me I'm going to use the F of X function, right? So what this means is that, remember I talked about functions are like the Hershey Kiss factory. You've got the machines, which is the function, that's your machine. You've got the ingredients, which are your X's, that's what you put into the machine. And then your Y, right, is the Hershey Kiss that pops out at the end of the end of machine. So you put all the ingredients in, that's your X. You run it through the machine, which is your function, and then out pops the cute little Hershey Kisses, which is your Y, or the result of what you get when you put your ingredients into the machine. Okay, so this right here tells you that it's F of X. Whoops, I always forget to go back over to the pen. This tells you right here that it's F of X. So what that means is F of negative 2, that tells you that for the X in your machine, your ingredients is negative 2. So everywhere in the machine that you see a X, okay, everywhere where you see an X, you're going to put in the ingredients negative 2. So let's write out our function here, or our equation. So this just tells me I'm using the F function, and this tells me that the ingredients I'm plugging in are a negative 2, right? I'm just rewriting this part, this whole thing right here. So what this means is I'm going to take my machine or my function, and I'm going to write it out. 3, I'm going to leave my X blank, right? That's my ingredients. And now my ingredients that I'm told to plug in is negative 2. So all you do is you take your ingredients and you plug it in where there is an X in the function, okay? So this right here is just directions. It's not something you work, you don't solve it. Remember, I could replace this, if it helps, right? I could replace this with a Y. Okay, now that makes sense, right? My function, F of negative 2, is 3x plus 2. And this gets a little, all the arrows and stuff that I used to point, it gets a little crowded. So, F of negative 2, the F tells me to use the F function. The negative 2 tells me to plug in that negative 2 as my ingredients into the function. So I've rewritten my equation, and I don't care if you write Y, I don't care if you write F of X, I don't care if you write F of negative 2, it doesn't matter, because basically this is your input, your ingredients, this is your output, or the result once you run your ingredients through the equation, okay? So let's evaluate this now. So we have, remember PEMDAS, I'll write that up here. Remember PEMDAS is parentheses, exponents, multiplication, division, addition, subtraction. So in order, we're going to take care of parentheses first. Well, parentheses here means we distribute or we multiply 3 times negative 2. So when I do that, I get y equals 3 times negative 2 is negative 6 plus 2. And then next on PEMDAS is addition and subtraction, and negative 6 plus 2 is negative 4. So f of negative 2, that just tells me I use the f function and I use the ingredients of negative 2, equals negative 4. So when I use the f function and I use the ingredients of negative 2, my result is negative 4. Okay? So let's look at number 2 here as an example. H of x plus 2. Use your brackets, okay? This is very, very, very important to use your brackets. So I'm going to put a bracket just around the x, and I'm going to put a bracket just around this x. I'm not going to include any of the squareds or the 2x outside or anything like that. I'm just putting a bracket around my x. Oh, whoops, look what I did. I used the wrong one. Nope, that's my fault. I wasn't doing them in order here. All right, h of x, right? H tells me to use the h. So this is this identifies h of x plus 2, means I'm going to use the h function, and I'm going to put brackets around each x, and then this is my ingredients right here. So my ingredients go anywhere where there is a bracketed x. So let's write this out. All right, so we have our h of x equals, now let's use black. I like that better. And then I'll use the red for the brackets. All right, so I've got my h of x equals, right here. My h of x, that's what I'm using. 3, I'm going to use my brackets here, x plus x plus 2. Okay? Hopefully you can see that what I just wrote matches this perfectly, right? H of x equals 3x, I left my brackets open, plus x plus 2. Now, I'm going to look at my ingredients here, and my ingredients, or my directions here, say that everywhere where there was an x, I'm going to put x plus 2. Okay? I'm just plugging in my ingredients everywhere where there's an x. Remember, this is just your ingredients that goes everywhere where there was an x. Okay? All right, so now it comes time for PEMDAS. Parentheses first. Well, parentheses say that I distribute first. So I've got equals, right? 3 times x is 3x. 3 times 2 is 6. Now here I've got parentheses, and what am I distributing? Well, I'm just distributing a plus 1, right? Because we always know there's a 1 out there. So if I'm distributing a plus 1, 1 times x is just x, and 1 times 2 is just 2. And then I've got this plus 2 dangling out here at the end. Well, now it's just a matter of combining like terms, right? I have got a 3x and an x. Well, 3x and 1x equal 4x. And they're on the same side of the equation. So I'm not subtracting and moving anything. I'm just combining like terms. Then I've got 6, a 2, and a 2. Well, 6 plus 2 is plus 10. Now, I can't combine this anymore. I can't get any better because 4x and 10 are not like terms. So I cannot combine this anymore. So when I take my h of x plus 2, right, when I use my h function with my ingredients of x plus 2, my answer is 4x plus 10. And you can't get any more simplified than that, okay? That's your answer. You just leave it just like that. All right, so now let's look at number 3, and I keep getting these content error links because people are trying to log in before I've posted a video. So hang tight, guys. I'll be posting a video. And once I post this video, obviously you're watching it now, so it's been posted, and now you can take notes and do your assignment. All right, so I'm going to have to erase here to give myself, oh no, I've got room. Okay, so let's look at number 3 here. What all have I got going on? All right, so I'm using my g function, right? So I'm using my g function, which means I'm going to use this right here. This is my g function, and this is my ingredients. Okay, now this one gets a little tricky, but inside the parentheses is my ingredients. So if I come over to my g function, right, and I put brackets just around each x, I'm going to plug the ingredient -4 into where there's an x. Now, what does this plus 3 out here at the end means? That means then when you get done and you get to almost your answer, at the very end, you're going to add 3 to whatever your answer is. So it's really important not to forget that 3. So I'll show you how I do it to not forget it, and I think it works good. All right, so my g of x, right? My g of negative 4 plus 3. My g function up here, right? I'm just looking at this is my function right here, is x squared, but I'm going to use brackets for x because that's my ingredients that I'm going to be plugging in here. So x squared plus 2 times x, and then I don't want to forget it, so I'm going to put this plus 3 here at the end. I'm just going to tack that on. Remember that? I'm going to add at the end. I'm going to do all of my function work first, and then I'm going to tack that plus 3 on at the end. So I've got my function is x squared plus 2x, right? That's right here. X squared plus 2x. So that's my function. My ingredients, or what it tells me to plug into my function, is negative 4. Those are my ingredients. So I'm going to plug a negative 4 in to my x spot, right? This is your ingredients getting plugged in everywhere where there's an x. And now I'm going to evaluate just my function. I'm going to ignore that plus 3 right now, right? That's what I'm going to do at the end. I'm just going to leave it tacked on there so I don't forget it. So PEMDAS says parentheses first. So I've got negative 4 squared, and I'm going to do my parentheses here. And my parentheses say to take 2 times negative 4, which is negative 8. And then I'm going to keep that plus 3. I'm just going to keep dragging it down with me, okay? I'm not going to really mess with that right now. Now, PEMDAS says to do exponents. Well, negative 4 squared is positive 16 because negative 4 times negative 4 is positive 16, and then minus 8, and then I'm going to keep dragging that plus 3 down. Now I've got 16 minus 8 is 8. I'm going to keep dragging that plus 3 down, and then at the very end, I'm going to do 8 plus 3, and so my final answer for g of x is negative 11, equals 11. Okay, you'll notice that this little plus 3 out here, I just kept dropping it down until I was ready to actually add it. So anytime you have something outside of your parentheses, it's an afterthought, a last-minute afterthought that you do at the very end, and you add it at the very end after you have already evaluated, right? I evaluated my function, my g, using my x squared plus 2x, and then at the end, I tacked on that 3, okay? All right, let's do another example here. So my problem here is h of negative 2 and then minus 2. So you'll notice I have this minus 2 to be tacked on at the end, and you'll notice it's telling me to use my h function. So let me go up and grab my h function. All right, so let's erase all this that I've written on it so far just to make it kind of a clean slate. All right, here's my h function, okay, right here. So I'm going to rewrite this just so I have it close by. So my h function is 3x plus 2. So my h function, right, my h function is 3x plus x plus 2, right? That's the function part. So what this tells me is the ingredients right here of negative 2 get plugged in here and here, right? Because those are the two places. This is h of x, right? So that means my ingredient of negative 2 is going to get plugged in everywhere where there's an x. And then at the end, right, I'm going to do this minus 2. I'm going to tack that on at the end. So let's look at just the function part right now. So my function is 3 and then x, right, plus x plus 2. That's just my function. And then I tack on that minus 2 at the end because that's this thing. So let's fill in my ingredients. My ingredients are right here, right, negative 2. So negative 2 is what this problem tells me to plug in for the ingredients. So let's evaluate this using PEMDAS. So let's do our parentheses first. 3 times negative 2 is negative 6. That's just a plus 1. And plus 1 times negative 2 is negative 2. Plus 2, right? That's this section right here. And then, as always, I keep dragging down my minus 2, right? Because I've got that too. Well, now I have just a big long stretch of pluses and minuses, so you can do this in one step if you want. You've got negative 6 minus 2, which is negative 8, plus 2 is negative 6, minus 2 is negative 8. Okay? So my problem for number 4, when I use the h of x function, is negative 8. Okay. All right, let's look at number 5. This is a nice basic one, but it tells us to use the g function. So I'm going to erase all this and make it clean again. All right, so looking at our g function, right? Here is our, oops. Here's our g function. So I'm going to write that down here again, right? So I've got my g function, which is g of x equals x squared plus 2x. I just rewrote it, okay? So this is my g function. And so I know I'm using the right one because this is my g and I'm using my g function. Now my ingredients, right? My ingredients here are a 5. So what that means is everywhere, just in my equal, after on the right side of my equal sign, everywhere where I see an x, I'm going to plug a 5. Okay? So what's that going to look like? It's going to look like my g of x is going to look like, right, remember to use your brackets. So it's going to be 5 squared plus 2 times 5. Okay, everywhere where there was an x, I plugged the ingredients of a 5 in. Now, it's important to use your brackets because if you're, just like we had up here in example number 3, I plugged in a negative 4, right? And then I squared a negative 4 and I got positive 16. It's really important to use your brackets because if you don't use your brackets, you're liable to lose a negative sign, okay? So now let's evaluate this. 5 squared is 25. 2 times 5 is 10. 25 plus 10 is 35. So my number 5, my answer is 35. Okay? There was no extra tacked on to the end, so there was nothing to keep dropping down and do at the end. So that would just be my final answer. All right, last but not least, we've got an f function, right? So this tells me I'm going to go up here and find my f function. Well, right here is my f function. I'm going to rewrite it down here so I have it. So I've got f of x equals 3x plus 2. That's my function, right? So f of x, yep. All right, so I've rewritten my function so I have it. Now, again, find the x in your function and find your ingredients. Well, here's my ingredients right here, x plus 4. So everywhere where there's an x, I'm going to put the ingredients in of x plus 4, and then I've got this little plus 1 that I'm going to tack on to the end and do it last. Okay? So let's do just the purple part, just the function part first. So I've got f of x equals, this is number 6, 3 times, well, now there's an x, so I'm going to plug my ingredients, x minus 4, all right? And then this plus 2, this purple plus 2 is still part of my function. And then this blue plus 1, that's that extra 1 I tack on at the end, okay? Because it was out here on the end. So now I'm going to do distribution first, right? Because PEMDAS says I do that. So 3 times x is 3x. 3 times negative 4 is negative 12 plus 2. That drops down. And then I still have my little plus 1 that I've got to take care of at the end. Now, what have I got here that's the same that I can combine, like terms, right? Do I have any other x's? I don't, so just 3x. And then I've got a bunch of whole numbers here. I've got negative 12, positive 2, and then that positive 1 I can do also. Those are all numbers. They're like terms, so I can combine them. So negative 12 plus 2 is negative 10, right? And I'll just do this in 2 steps just to, whoops, keep that blue to keep it straight. I'll do this in 2 steps just to kind of break down, but you can do this in 1 step. And then 3x minus, well, negative 10 plus 1 is 9. So this is your final answer. Cannot be reduced anymore because 3x and 9 are not like terms, so they cannot be combined. So it stays 3x minus 9. Okay, if I had other x's, I could combine that with the 3x. But since I don't have any x's, I just have numbers. All the numbers get combined, all the x's get combined, and then they stay separate at the end. Okay? So the main thing to take away from this is that you have, right, different functions, and we just name them f, g, and h so we can tell them apart. And the important part is this right here, right, at the end. This is your function. That's your machine. For g, right, this is your machine. And for h, this is your machine or your function. And so when you're given a problem that says f of, you know to use the purple one, or the f of, and you know to plug the ingredients into just where there's an x. And you've got to use your brackets, right? The ingredients go in where there is an x, and you have to use your brackets, and then you distribute and whatever. Here you got to make sure and use your brackets, right? Make sure and use your brackets. And here, make sure and use your brackets. Okay? All right, that's all I got for you today. For your homework assignment, you have got there at the bottom, numbers 14 through 24 are different, and you just have f and g, right? So if it says f, and then like number 14 says f of 4, that means you're going to use the f function. And on the right-hand side, that 2x minus 5, anywhere where you see a x, you're going to plug in the ingredient 4. If you skip down to number 20, that's the first one where you see that extra number tacked on at the end. Just keep dragging it down, leave it dangling out at the end like I did. I did it all in blue every time. Leave that plus 1 dangling out to the side, and after you evaluate f of 2 by plugging in a 2 everywhere where you see an x, then you add that 1 to the end, and you carry it down with you. Okay? All right, email me if you have any questions. I will upload this video right now, and then we will go over this tomorrow and do a quick review, and then we will quiz on indicator 11 on Friday. Hope you all have a good day, and I'll see you tomorrow.